We move ahead with some more discussion regarding impulse mass filter response. In this, input is for a particular input, we calculate impulse response of match filter. Impulse response of match filter for a particular input xt st output. We calculate impulse response of match filter st. For calculate the output of match filter is match filter is which come from xt convolution st. So we have to convolute these two terms. If input is given to us, basic input as, as from starting xt st is, then find convolution between these two. For convolution, first idea, we add lower limit and result will be expanded in 0 to 2t, and we construct if same type of duration pulse is convolute with each other, result will be triangular pulse. Range is come from here 2t. Height of this triangle is area of this t, area of second one is 2t t. If we multiply these two, t square is our complete area. In this pattern, as per convolution property, y equals to x a h. Area of first, area of second, result is this. Area of first, area of second is result. Area for this is half base into height, means height is 2. Sorry, height is t. If height is t, our result is same, means height is t. A triangular pulse with height t, base is 2, answer of output of match filter for given input. We can proceed further. If we apply this type of input t by 2 and t, match filter impulse response is we already drawn. Then convolution of these two is, to calculate convolution, first idea is adding lower limit is 0 and its upper limit is t by 2. Its lower limit is t by 2 and upper limit is t. Result will be in the range of 3t by 2. T by 2 to 3t by 2. As per this result, we know about match filter response. SNR at t equals to capital T is maximum 2 EB upon N naught, which is always maximum. Maximum value at match filter output is at particular location t equals to capital T, always. Or value of that SNR is 2 EB upon N naught. We know that. Now area of this pattern is, if we consider one here, maybe a here, any value here, area of this pattern is t by 2. Area of this pattern again t by 2. The complete area is t square by 4. So whatever exists here is triangular pulse, because both are rectangular. Duration is mentioned as, so area is t square by 4. To make t square by 4, difference is t base height, half into base into height. Height may be t by 2. If height is t by 2, complete is, this expression is complete. We know everything about this term. So for this type of input, we have this is the result. This is our result from t by 2 to 3t by 2. 2 EB upon n naught. That that is our result. Move to next question. GATE 2006 question. A pulse pattern is given to us and calculate match filter output response for this. We already discussed match filter impulse response of this pattern is A minus A t by 2 t, A minus A t by 2 and t. We want to convolute these two patterns. What will be the result? Result will be in the range of first pattern is 0 t, range of second pattern is 0 to t, 2t. Find convolution between these two terms, we are sure about answer will be center at t, range will be 2t. I draw directly answer 3t by 2 t by 2 a square t by 2 negative a square t. I directly draw the answer. This answer may be come from area property, but it is not possible because there is positive and negative both type of area, so area property is not useful there. We can convolute these two pattern and get this result through Laplace also, which is very easy method. Lot of idea is there. We can directly convolute by putting mathematical expression in this, which was very typical. If I write down mathematical expression for both ut minus a 2 plus ut minus capital T, this expression convolute with minus a ut minus plus ut minus capital T. If we convolute these two terms, take Laplace and convolute them. I took Laplace and convolute. I want to convolute these two terms. By taking Laplace of first term, because convolution between two pattern is equals to multiplication in frequency domain, either in Fourier or in Laplace or in Z. If continuous signal, Fourier and Laplace. If discrete, Z. So we use a upon s minus 2 upon s e power minus st by 2 plus e power minus st, multiply with minus a square come out because a is common in. Once we get the solution and we get the desired result in graphical method, we we have to take some common component s square and then result will be whole square of it, and we will get desirable result minus 1 minus 2 e power minus s plus minus st whole square. Make it arrange in accordingly, so graphically we can represent this. This will be our answer, and by putting value we can also expand this term, square term, and take inverse, result will be appear. One more question we will discuss of gate 13. In that question, in gate 13, xt is e power minus pi t square, ht is e power minus pi t square. Output of match filter, input and match filter impulse response is given to us, and output of match filter in frequency domain, what will be the answer? This is the gate 13 question. To calculate in frequency domain, x omega multiply with h omega. In this case, h omega to calculate impulse response output in frequency domain, st is xt convolution st. We have to convolute these two terms. Answer will be in frequency domain, so we can multiply the Fourier transform of given parameters. So we can directly write Fourier transform of x omega is, we know that for Gaussian pulse Fourier transform is e power pi f square. X f, not omega, e power minus pi f square, h f equals to e power minus pi f square. X f equals to x f dot hf. Multiplication between these two. If we multiply these two terms, 2 pi f square will be the answer. One more question we will take. In this question we will discuss a match filter is given to us, xt is input, and with some delay amount it added at location st is in series block, in cascade, in series block st is there, and result is yt. Find the impulse response of filter. We want to find out the impulse response. This is the new type of question. We want to find out the impulse response of this. To find out the impulse response, apply impulse as input. If we apply input as a impulse, here we get 1 second delay, means this. At summer output, what will be the result? Impulse and 1 second delayed impulse. This impulse convolute with st. This impulse convolute with st and get us a result. This st is given to us. St is 1.5. St is given to us ut minus half. This pattern convolute with st, result is yt. So in this way, yt comes from del t minus 1 convolution with ht, ut minus half. Because this term is ht, impulse response of filter given to us, which is drawn as 1.5, and this is the input applied. If input applied is impulse, we get impulse response in any case. Impulse response of that particular filter, which is known as match filter, we want to calculate match filter, hmt, come from convolution between these two terms. If ut convolution with del t, result is ut. Ut convolute with ut minus half minus 4 terms. ut convolute with t minus 1 and last plus ut minus 3 by 2. All the term we mention here, and we can draw this way. And second one is second I draw in this way. This is plus and minus. Second I draw in this way, 1 and 1.5, because in this case when we apply impulse, here is summer, so impulse response is plus, and again plus here we multiply, we get result in this way. This is impulse response. Question b said us find the impulse, find the pulse say st which is match with this filter. We want to calculate match filter of this. To calculate match filter of this pattern, a pattern is given to us 1.5, 1 and 1.5. To calculate match filter of this, just negative of this pattern. By negation we get this result. This is called h of m minus t. If we want impulse response of this is the impulse response shifted by 3 by 2. If I shift it by 3 by 2, it is half, again same, 1 and 3 by 2. This is match filter response of input, if input is this. In third question, sketch the output response yt if hmt, match filter response hmt, and input st convolute. Convolution between these two convolution between these two, first term and second term. For calculate the convolution between these two, result is range of the signal. First term is start from 0 to 3 by 2. This also start from 0 to 3 by 2. Same type of pattern. Use graphical method to convolute. Result will be in 0 and 3 by 2. 3 by 2 is 3. Result will be 0 to 3. And what is our result? Result will be in this pattern. By graphical method we can solve this, or by taking Laplace transform we can solve this. Some calculation is there. I also write expression for both, calculate step by step. In one, this is our final answer output. How it come? HMT is UT U of half plus U of 1 minus U of 3t by 2. This component convolute with itself. We can apply area property also. By convoluting these two terms, we have to take Laplace of these two terms. 1 by s 1 minus e power minus st by 2 plus e power minus st minus e power minus 3t by 2. Both are similar type of term, s square. Expand this term, take inverse, we get this type of result. With this, I end this topic. Match filter. Match filter is very important topic. In match filter, basic three criteria. First, calculate impulse response for given input ht. ht come from x t minus capital T. Actual formula is this, because all signal are real signals, so conjugate sign is eliminated. Result will be this. Second is yt. Output of the match filter response is come from convolution between st and xt. This is solved through by taking Fourier transform or Laplace transform. This idea is very easy. Laplace transform to calculate output. Third type of pattern is capital T. Answer at capital T, which is fixed 2 EB upon N naught due to a property T equals to TB. SNR is maximized due to matched filter property. SNR is maximum at T equals to capital T 2 EB upon N naught, where EB is bit energy, N naught is power spectral density of white noise two-sided. In this way, regarding match filter, we discussed lot of questions of gate and other question also. Thank you.